Okay, this is a discussion about what is a literal equation, or what does it mean to solve a literal equation. And basically what that means is solving for a specific variable in terms of other variables. And why do we do this? The main reason we do this is for convenience, because sometimes it's helpful, really useful to solve for a variable in terms of another one, just if you need it to be able to calculate easily. So suppose, I think you're familiar with this equation, distance equals rate times time. So let's just suppose that we have this formula and we want to know how long it takes to travel different distances if we're going at a certain rate. So let's just say we're traveling, our rate is 65 miles per hour. And we want to know how long it takes to travel different distances. So let's say, how long will it take to travel, say, 100 miles or 250 miles? Or maybe 150 miles. Well, we can use this formula to find that, but it's going to be way easier if we just simply solve for t, the time. How would we solve for time? This is an example of solving a literal equation. Well, we want it by itself, so we'll divide both sides by r. R divided by r is 1, so we get that time is equal to the distance divided by the rate. Well, in this case, the distance is 100 miles. So if we want to know the time it takes to travel 100 miles, the time it takes to travel 100 miles would be the distance divided by our rate of 65 miles per hour. The time it takes, T1, T2, the time it takes to travel 250 would be 250 divided by 65. The time it takes to travel 150 would be 150 divided by 65. So you see that once we have solved for t, it makes it really easy to solve this problem. I've already done the division, and so this is, if you're curious, it would take 1.53 hours, so about an hour and a half, a little over that. This would take 3.85 hours, and this would take 2.3 hours. Okay, here's another example of when it's useful to solve for, of why we might solve for one variable in terms of another. Let's just suppose you had a thermometer that only measured in Fahrenheit, and you needed the temperatures in Celsius. So you're able to measure in Fahrenheit, but you need it in Celsius. Well, we should solve for C. All right, well, how would we do that? You could multiply both sides by 5. I call this killing the fraction. Whenever you have a fraction, you can get rid of it by multiplying both sides by the denominator. On the left, we get 5 times the degree f. On the right, we get 5 over 1 times 9 over 5c plus 5 times 32 is what we get when this distributes. So these will cancel, and we'll get 9 times c plus 160. And then we can get 5f minus 160 is equal to 9 times c. And then we can divide both sides by 9. So we get this, that degree c is equal to 5 over 9 times f minus 160 over 9. So that's one version of it. If you want to factor out the 1/9, that's fine. If we want to factor out a 5 from the 60, you can also write this as 5 over 9 times f minus 32. And this version makes it real easy to calculate if we say this is what degree C is equal to. So let's say we had a thermometer that measured 58 degrees F, 92 degrees F, and 80 degrees F, and we wanted to know what that was in C. we could just put this right here for f and calculate it. And it turns out that this is 14.4. This is 33.3. This is 26.7. And just by sticking these values in here for f each time, that makes it really easy to calculate. Or here each time, that makes it really easy to calculate. So that's what literal equations are, and that's why we do that.